All right, everybody, welcome back to another OpenShift Commons briefing. Today, as we are wont to do on Mondays, we are bringing one of the upstream projects that is one of the more important workloads on right these days. Not that your workload is not important, but one of the more interesting ones, OpenDataHub, the AI platform and team, to come and tell you a little bit about this project at Red Hat. And we have a number of members here, Lana, Vaclav, Chad, Landon, and Beverly. Landon LaSmith is going to walk us through first a little overview of what OpenDataHub is, and then we're going to open it up to Q&A and have an AMA session on this, as we like to do, and have a little bit of a demo of it. So queue up your questions wherever you're watching this, whether it's Facebook, Twitch, or YouTube, or if you're in the Blue Jeans. And we'll aggregate those questions and answer them, hopefully, after the demo and lecture part, and have a conversation about what OpenDataHub is and how to use it. So take it away, Landon.
Hi, as Diane stated, my name is Landon LaSmith. I'm one of the engineers on the OpenDataHub team, along with Joanna, Vacek, and Chad. So I'm just going to give a quick overview of OpenDataHub, and hopefully we can answer all of your questions. Right. So in this slide, we're going to cover what is OpenDataHub, give a brief introduction to Kubeflow, which is our kind of upstream project that we're in sync with, kind of tell you where OpenDataHub is used, and just do give you a quick demo on how you can deploy OpenDataHub. So what is OpenDataHub? The original goal of OpenDataHub is to build a platform for data science. So we want to make it as easy as possible for a data scientist to stay within their workflow. So we know that they have many tools that they use for model training, model development, model serving. We wanted to make that as easy as possible to do it on OpenShift. OpenShift allows us to kind of scale out to different needs and configure the workflow exactly how they want to do it. One of the issues we try to tackle is to make it so that everybody on the team can contribute to the data science workflow. We want a team of data scientists to be able to work on shared data using some type of storage, use an environment, a development environment that they're comfortable with, in this case, Jupyter Notebooks, but also allow kind of data engineers and DevOps to work within that workflow to create the best solution possible. So this began what we are now calling the OpenDataHub. OpenDataHub is not a official Red Hat product. It is a community project. We set out to create a reference architecture to provide best practices on how you can deploy these different tools within this data science workflow. We have a lot of information on these best practices, how to deploy OpenDataHub, how to use different components of OpenDataHub on our website at OpenDataHub.io. And the core part of OpenDataHub is the meta operator, or the meta project, the OpenDataHub operator. So with this operator, we can deploy different tools that will be used in the workflow for a data engineer, the data scientist, and make it easy for DevOps to deploy this project. So if you want to deploy the OpenDataHub, you can find that on any OpenShift cluster under the operator hub on that cluster, and look for OpenDataHub. It is a community operator that's available to install for free, no Red Hat subscription required. So the OpenDataHub ecosystem combines a lot of different parts where we gather input for best use cases, best practices for OpenDataHub. So we work with a lot of customers, internal and external, to kind of lay out how we want the OpenDataHub to proceed. So we take public requests. You can contribute to the OpenDataHub. We work with Red Hat partners to see, if their tool helps further the OpenDataHub. And we work with a lot of upstream components that have downstream projects within Red Hat. So our goal is to use completely open products within the Open Data Hub, and also provide a path where you could kind of substitute in these downstream products if necessary. But everything is freely available. So this is kind of a few of the components that are in Open Data Hub in this nice graphic. We focused on kind of Jupyter notebooks for the development environment, object storage provided by kind of Ceph, Apache Spark for data engineering, Seldon for model serving, Argo workflows are kind of the core pipeline technology that we've used in the past. Prometheus, Grafana, TensorFlow, and Kafka. So with the recent release of OpenDataHub 0.6, we're currently on version 0.7, we are an official downstream of Kubeflow. So the Kubeflow project is a project to bring together all these data science tools into a ecosystem that works on Kubernetes. And we do the work to make sure that this workflow also works on OpenShift, but we also bring in a lot of products that aren't covered by Kubeflow. And all of this is available on Operator Hub. All right. So this is a graphic kind of our original release. So a little bit of backstory about OpenDataHub. Probably a year ago, we had our official release of 0.5. This contained a few of the components, which were Jupyter Hub, data catalog for that contained QHive and Thrift, GPU support, Argo, and all in the Ansible operator. With the switch to kind of downstream Kubeflow, we refactored or updated the operator so it's purely based on Go. It works with the KF-Def manifest, and it fully supports Kubeflow products. So using this OpenDataHub operator, you can deploy Kubeflow on OpenShift in addition to OpenDataHub components. So the current release is 0.7. You can see a few of the components we have released. So we have full support for Kubeflow version 1.0. You can deploy that with our operator on OpenShift. KF serving support with our operator. And I think this might be mixed in. We can use this with OpenDataHub. Full CI testing on all of our updates and releases. So as soon as we submit any updates to OpenDataHub, we run a full battery of CI tests to make sure that new component doesn't break any existing functionality, but also provides working new functionality. You can mix and match ODH and Kubeflow components. So right now we're verifying a small subset, but with the 0.8 release, we plan to verify and test kind of all of the default Kubeflow 1.0 components mixed in with ODH components and some OpenShift container storage. So the current operator for OpenDataHub is kind of a phase 1 basic install. This means that it will deploy OpenDataHub and do some minor updates, but for the most part, we're doing a full install. We have plans as time goes on, throughout the year to kind of bring this into a phase 5 operator, but these are long-term plans. But as of right now, you can deploy your OpenDataHub ecosystem architecture on your OpenShift cluster without any issues. So Kubeflow. Kubeflow, for those that may not be aware of it, is an open source project dedicated to making deployments of ML workflows on Kubernetes simple, portable, and scalable. A lot of the work we did to bring OpenDataHub in line with Kubeflow is to make sure that there are no issues when deploying from Kubernetes to OpenShift. We had to introduce a lot of updates and fixes to make Kubeflow more secure. We want to make sure that not every container is running with root privileges, that you don't have to elevate any container privileges beyond the standard runtime permissions. And And then we kind of verify and make sure that model training and serving works on OpenShift. So these are a few of the goals. This is for OpenDataHub and working with Kubeflow. We want to incorporate best practices. A simplified install. We want to use the kind of UBI or universal base image as the base for all of the OpenDataHub components. This provides anybody deploying OpenDataHub with a level of security that comes with using that UBI base image. So you get a lot of the Red Hat effort for providing a secure base image in OpenDataHub. And we also want to make sure that we secure that deployment of OpenDataHub and by extension, Kubeflow, so that it's using kind of well-defined permissions. We kind of eliminate any containers that require root privileges and work within the kind of standard deployment, standard secure deployment that OpenShift provides. So this is a kind of a quick graph of some OpenDataHub components that we are bringing to the new release of 0.7 or 0.8. We're working on kind of allowing you to deploy storage along with OpenDataHub based on Ceph object storage. We have support for, I guess we have components that are using Postgres. But as of right now, you can deploy Kafka, and we have you can deploy Spark clusters. We're working on updates to provide kind of data exploration. So we do have Superset, which allows you to do data visualization. So you can work directly with kind of your external databases or data sources to visualize that data. We're working on adding data cataloging with Hue so that you can kind of navigate your object storage, but also run Spark SQL queries on that data. So we're hoping to get that into the next release. And we currently, I think we do support with the ability to mix OpenDataHub and Kubeflow components for TF serving. I think PyTorch is in the final verification steps. We do deploy support Seldon model serving, and Argo and Kubeflow pipelines, along with monitoring by Prometheus and Grafana. And like I said in the bottom right, our data scientist kind of workflow includes JupyterHub. So we fully support OpenShift authentication for those notebooks. So JupyterHub being a multi-user notebook server, a team of data scientists can work within their own notebooks separate from each other, but potentially share data either through object storage or even sharing notebooks via their allowing others to access their notebook pods. And all of that is fully integrated with kind of a Spark cluster that you can deploy. And we have our AI library with kind of example AI models that you can utilize for your workflow. So if you want to join the OpenDataHub or follow it, as always, feel free to go to our website at opendatahub.io. We are fully functioning on github.com/OpenDataHub-IO. So if you want to track any issues or progress that we're making in the project, all of our OpenDataHub projects exist under that organization of OpenDataHub-IO. Again, we're a community project, so feel free to kind of take a look, file issues if something doesn't work correctly, or submit PRs. So if you see an issue or you want to add a new feature, definitely go there and submit a PR. If you want to track progress, we have an announcements list you can subscribe to, and then a contributors list if you go the extra mile to submit PRs and want to become a contributor. And then we have bi-weekly OpenDataHub community meetings that you can track archives on our GitLab site. So I want to clear up confusion. So our old operator exists on GitLab, but to make sure that we can stay in sync with kind of Kubeflow updates and become a fully functioning downstream of Kubeflow, We migrated to GitHub, but a lot of our old projects are still on GitLab, the OpenDataHub community being one of those. But it's still current for the OpenDataHub community, so you can see old meetings, get notes from any of the meetings where we have a lot of guests present, any use cases that are utilizing OpenDataHub, or kind of volunteering or opening the discussion to add new features to OpenDataHub. So this is kind of some examples of where OpenDataHub is being used. Originally, OpenDataHub was an internal project that started with a basic Elk stack, if I remember correctly, and we worked with internal customers so that they could kind of work with their data in an easy fashion. So we provided the storage and Elasticsearch to interact with that data. And from that, we got a lot of customer use cases that helped to form the OpenDataHub. So a lot of the work internally, we transitioned to the OpenDataHub so that some of our experiences with this type of workflow can be utilized by the community as a whole. A few of the early adopters for OpenDataHub, the Massachusetts Open Cloud. It's a collaborative effort of a few universities to kind of run their data science and high resource workloads on a open, high availability cloud. So OpenDataHub is kind of part of the backbone for some of this work, where kind of professors, researchers, and even some students can get access to run their OpenShift or data science workflows. So I'll give a quick demo. I just want to demonstrate how you can get access to the OpenDataHub and deploy it within your workspace. So let me kick over to my OpenShift console. So here I have a basic OpenShift cluster. Potentially you could deploy this on any OpenShift cluster. So right now I'm using a 3-worker node cluster. So this is pretty standard for any OpenShift install. We do have support for deploying on something as small as a CRC or code-ready containers cluster. You could also use OKD, which I think just went GA or general availability for OpenShift 4 clusters. So right now, the current iteration of OpenShift or OpenDataHub supports OpenShift 4.x. So the current version is 4.5, which I think was released last week or 2 weeks ago. So any of the freely available OpenShift clusters can be used to deploy OpenDataHub. But if you go down to kind of CRC or OKD on your laptop, you'll need to scale it accordingly. So if you want to deploy OpenDataHub, you can log into any OpenShift cluster and go to Operator Hub. So this should be available in every single OpenShift 4 cluster. And you search for OpenDataHub. Actually, let me backtrack. Let me go ahead and create the namespace. So just create any namespace. I use OpenDataHub. And here you'll see OpenDataHub Operator. And again, it's available as a community operator, which means it's freely available for anybody to deploy on any OpenShift cluster. And you'll get kind of a rundown of the current components that we deploy as part of the OpenDataHub, with additional info about where you can track the project, the operator image, where we're pulling the operator image, and additional information. So this kind of describes the available channels that you'll see in the next step. So when we click install, we're presented with these standard options for any operator. The current iteration of OpenDataHub is a cluster-wide operator, which means that we can deploy any KFDEF custom resource that the OpenDataHub watches for into any namespace in the cluster, and the operator will see that and deploy OpenDataHub. The update channel is beta, beta is what you want to use right now. That is where we're hosting our new operator. Legacy is the older namespace bound operator. That is the older Ansible operator. That still works, but we are providing kind of minimal support for that. So a lot of the components that are deployed there will not be receiving updates since we're doing all our updates on the beta channel. And we'll leave the approval strategy as automatic. So this means that whenever we release newer versions of OpenDataHub, they'll be available and installed. The operator will update automatically. And hit subscribe. And now we're just waiting for the operator to be installed by OLM. OLM is Operator Lifecycle Manager. So we utilize OLM a lot. So in the older operator, one of the issues that we encountered was that we had to kind of recreate the deployment strategy for every component we deployed. So if we deployed Prometheus, we had to create the deployment objects, the roles, service accounts, every single item that was required to deploy a component, we had to bury that or kind of embed that into the operator image. Now, if there is a component that the OpenDataHub uses that is available in OperatorHub, so whatever component has put forth the effort to kind of be listed on OperatorHub, we can easily leverage that entry in OperatorHub for OpenDataHub. So we're not recreating the deployment the strategy or plan for every component. We can literally say for Seldon version 1.2, reach out to OLM and deploy that operator. So that's good because we aren't required to kind of stay in sync with their update strategy. So as Seldon updates their operator and pushes that to the OpenShift Operator Hub, we automatically get those updates for that version, and OLM will handle the kind of deployment strategy. So now that the operator is deployed for OpenDataHub, we'll just click on that, and you'll kind of get another overview of the deployment. So the OpenDataHub operator is looking for KFDef custom resources. So anytime you submit a KFDef resource, which is the essentially the customized manifest format for Kubeflow, once you create one of those on an OpenShift cluster, the OpenDataHub operator will see that, and based on the information that's in there, it will deploy it. So we'll go ahead and click Create Instance. And hopefully you can see this, but this is a sample KFDef or an example KFDef format that we provide. So what you can do is you can look through this and you'll see every entry in this applications dictionary has the same basic format. So customized config with a repo ref and a name. Customized config, repo ref, and a name. So this determines what is getting deployed as part of this KFDef. So here you'll see that we're deploying AI library cluster and AI library operator. One of the things that we set out to do whenever we add a component OpenDataHub is to kind of separate the cluster-wide permissions or cluster-wide actions. Mainly things like deploying to a cluster-wide namespace. I want to say checking for required CRDs exists in this kind of cluster component. And then anything specific to the deployment of the operator or application exists out there. So in this operator deployment, sorry. So a lot of these components will have two portions or two configs. So here you'll see Kafka cluster and Kafka. So anything that's not named cluster, so Kafka actually has the deployment files necessary for a Kafka deployment. Cluster is generally the CRDs and any required cluster-wide options. So as you look through this KFDef, you'll see all the components that we're deploying: Kafka, Grafana, the RAD Analytics Spark operator, Prometheus, Jupyter Hub. Jupyter Hub will be the entry point to a lot of the use cases for OpenDataHub, if you watch any demos or examples. Airflow, Argo, and so on and so forth. So with the latest release of OpenDataHub, this is kind of one of the new features we wanted to focus on. So you'll see in this repo section, we have KF manifests and regular manifests. So KF manifest is a fork, a downstream fork of the fixes and updates that are required to deploy kubeflow on OpenShift. So if you go to the github.com kubeflow/manifest, that is the pure vanilla kubeflow deployment that will work on Kubernetes, and they do have support for additional cloud providers, so Azure, let's say IBM, Google Cloud. But in this OpenDataHub-IO manifest are all the files and updates, fixes that you need to deploy on OpenShift. And this plain manifest, which is in the ODH manifest repo, this is the OpenDataHub proper. So these are components that we've specifically curated as part of the OpenDataHub reference architecture to deploy. So if you just deploy anything using manifest as the repo name, then this is the OpenDataHub implementation. If you see anything that references KF manifest as a repo name, then this is based on kind of the upstream deployment of kubeflow that we have added a few fixes to make sure that deploys successfully on OpenShift. So right now, I think everything just references manifest, but as the next version is released and newer versions, you'll start to see more and more mixing of kubeflow and OpenDataHub components. So potentially you'll see like the TF job operator, the PyTorch operator, maybe even some pipeline work. It just depends on kind of what we have time to verify before that release. So in order to deploy OpenDataHub, you just hit create. You'll see the KFDef file is created. You can view the YAML. And now we just wait for everything to deploy. So slowly you'll see kind of different components come online based on that KFDef, the AI library operator, Seldon controller, superset, so on and so forth. And once these pods come online, they deploy successfully, then you can start to use any of the components that are deployed. So this may take a few minutes, but that is kind of OpenDataHub in a nutshell. So I don't know, while we wait, if we just want to go ahead and open the floor to any questions.
Certainly, we always have questions. One of them, while you're doing this, maybe explain a little bit. One of the questions that's often asked is OpenDataHub available for generic Kubernetes, which kind of flows into the question about, is OpenDataHub available on OperatorHub.io?
So, yeah, so there's a lot of confusion between OperatorHub that you see in OpenShift and OperatorHub.io. So OperatorHub.io, the website, are for operators that are certified to work on vanilla Kubernetes. So not OpenShift, but the upstream Kubernetes server. So we are certifying that we work on OpenShift, which means that we are only available in the OpenShift Operator Hub that is deployed with all OpenShift clusters. So just because you don't see us on OperatorHub.io does not mean that OpenDataHub isn't available on OperatorHub. It just means that we're certifying that we work on OpenShift. So any OpenShift deployment, whether it's OKD, code-ready containers, OpenShift on AWS, OpenStack, if OpenStack or OpenShift is supported on any type of infrastructure, then you have access to OpenDataHub.
Yeah, and you did mention, and I'll mention this while we watch your screen scroll here, that OKD is now available, and OKD is the open source distribution of OpenShift, and it's available now as of July 15th in general availability, and it's running on Fedora CoreOS, but you should be able to deploy the OpenDataHub easily on OKD. And I don't know if anybody's tested that yet, but if you haven't, let me know. I'm one of the chairs of the OKD working group. We'd love to get your feedback on that and help you through it if there's any issues whatsoever. I don't think anyone on the ODH team has done that yet. It's probably too soon. That was just last week. So we'll definitely have to get that tested.
Yeah, and just to kind of build on top of what Diane just said, if you deploy it on OKD or any infrastructure provider, OpenShift cluster, and you're experiencing any issues, please submit the issue to kind of any of our projects. If something isn't working with the operator, add that to the OpenData or create an issue in OpenDataHub-operator. If any of the components aren't working correctly, then feel free to file an issue on ODH-manifest. If you are deploying kind of pure kubeflow on OpenShift, then feel free to file that on the organization OpenDataHub-IO/manifest. And if you file it to the wrong one, that's fine. We will definitely make sure it goes to where it needs to be.
Definitely straighten you out and point you in the right direction. And really, if you're listening to this and you are running this reference architecture or want to, please do reach out. We're definitely looking, I'm seeing it pop up in lots of conversations across the ecosystem, from healthcare to and COVID tracking stuff to all kinds of interesting things. So it's definitely been starting to get a lot of overflow into other spaces and market spaces and use cases. So we're definitely looking for more feedback, and any bugs, anything you find, send to us. So how's your demo going?
Everything's deployed. We're missing one key thing for Jupyter Hub, but I'll investigate that and we'll go from there. So we can open it to other components. Or questions. Let's see. Sets. So one of the things I'll say, whenever you deploy OpenDataHub, we make sure that everything's ready in a state where you can use it automatically. So if any of the components need to be accessible, so they're not just kind of back-end components where a component A is just utilizing a service from component B. If it's something that the user needs to interact with, we make sure that there's an OpenShift route created to that so that you can easily, once OpenDataHub is deployed, just go to networking routes and access that component. So here you'll see superset. So now that this has been deployed, it's ready to kind of interact with, and you can start your workflow from there.
What was the piece of Jupyter Hub that didn't deploy here? That was so.
Check. Let me see.
This is why we love to do live demos while we're live streaming, because it makes it much more interesting and people believe us that it actually works and it's not smoke and mirrors. And this truly isn't smoke and mirrors.
So we do have check the operator. I'm trying to see if there's any mention of Jupyter Hub. Okay.
Maybe while you're doing this,
Okay.
we can answer a few more questions, and I'll unmute some of the other folks that are from your team, and you can debug it and just raise your hand when you figure it out or not, and we can do that. So let's see, who else we have? Juana is here, and Valclav was here, Beverly's here. Hey, Juana.
Hey, how are you?
And it's Joanna, right? It's not
Yeah.
Juana. It's Joanna. And I'm going to just shoot myself because I ought to be able to remember that each time.
No worries.
Sorry. And Vaclav is here. So there are, while he's doing that, a couple of other questions, and I think you answered the one about in explaining where it is in terms of vanilla Kubernetes versus OpenShift. And I think we do have a pretty strong full open source stack with the complement of OKD now. So anybody who wants to do a full stack without licensing OCP could if they would. And I'll see if I can get the OKD working group to find someone to test it out for us. But one of the questions that came in, and Beverly is probably going to guide us through some of them. Maybe the first question, if you want to go through that.
Absolutely. So, Juana, are all components from Kubeflow available or included in OpenDataHub?
Actually, yeah, so not all of them are. For example, I can say KF serving today doesn't work with Kubeflow 1.0 that we have. And if you look at the example manifest, that is actually linked through our operator main page description, you'll see that some components are commented out, and these are the components that we are actually still working on to get them working in OpenShift. So it's a work in progress for us.
So Joanna, do you have, right now it's probably a heavily Red Hat led contribution base right now. Do you have people external to Red Hat contributing and helping out?
We do have very few people mainly opening issues and guiding us through fixing the issues. I wouldn't say we have major contribution, but we do have some contributors from IBM with regards to the operator contributing heavily there. I'm gonna add something, and I forgot what it was, but yeah, that's mainly what it is. Yeah, but our community meeting is always busy with many different developers from different companies, and we do work really close with many of the component owners, such as Selden and Kubeflow.
Yeah, so I think as this community expands, the end users become really important because they're giving the feedback to how it's being used, and the integration partners like Celadon and others become important too as well. So it'll be interesting to see how the ecosystem grows around this, because you have incorporated a whole lot of partner and integration points there. So that's going to be fun to watch as we go through. Yeah.
And Diane, now that you spoke about the end users, we also have a question on whether we have active use cases for OpenDataHub.
So we have, from a use case perspective, from an industry perspective, we do have one use case that's already out there, which is the fraud detection use case. So we have all the code and all the instructions on GitLab for it. And then we're working on a couple. We also have AI on the edge that Landon's working on, and then we're working on other industries. I think we have one in the banking industry, and a couple down the line coming down. Is that what you mean by use cases, or did you mean how is OpenDataHub being used currently?
I mean, well, that answers the question, but we could also look at it in terms of, do we have maybe like clients that are already
Yes.
using OpenDataHub in their infrastructure?
Yeah, so we do have a couple clients. We have a couple ExxonMobil using it, and they did many presentations with regards to using OpenDataHub. We also have internal implementation of OpenDataHub that is being used by internal data scientists and data engineers in Red Hat. And then we also have the MOC that Landon describes, and I'm sure Vashak can add a couple more about this and where it is today.
I also think
Yeah, sure.
yeah, Vaclav, go ahead.
So with MOC, we are working on support for OpenDataHub on Power 9 machines and Power 9 clusters of OpenShift. And we have OpenDataHub deployed in MOC and is being used by students for their research work. We had a couple kind of early adopter projects. I don't think that any of them is live right at the moment. But part of that is that since we have moved to mostly only supporting, well, supporting is the wrong word, but using and verifying ODH deployment on OpenShift 4 and MOC is still running on OpenShift 3. It's been kind of hard to keep it running there. So we are working with them. We have weekly syncs to basically see where they are. And when they have OpenShift 4 ready for us, we will come back to having OpenDataHub fully running there. Part of our roadmap, which you can find on OpenDataHub.io as well, is for the next release to have a plan for how we could do continuous deployment. Landon mentioned we have an internal deployment of OpenDataHub, which is running internally at Red Hat. And then we have that partially public deployment on MOC, where the researchers that are part of Messages Open Cloud can use it. And our goal for the next release will be to come up with a plan for reproducible continuous deployment solution or process rather, where our new releases of OpenDataHub would go to our internal DataHub instance and to MOC deployed instance. And it would be hopefully also reproducible for our users, where they can use that process to also like get their deployment bound to our releases and stuff like that.
I saw on your roadmap as well is that you were thinking about disconnected deployments.
Yeah, definitely. It is a big ask, and not only for OpenData but also for the Kubeflow, the upstream project that we pull components from. There is plenty of people that are running disconnected, be that with edge deployments or generally on remote locations where they maybe only have mobile connections or something like that, and they need to be able to make sure that they can control the traffic that is coming in and out of the clusters. So we want to make sure that that is possible with OpenDataHub, and when deploying, that like everything goes kind of smoothly. They can pre-pull the images and they can deploy to a disconnected environment whenever they are ready. So we'll be looking at that probably this fall. We've been looking at that for some time in our previous versions, which was based on Ansible Operator. But it was kind of hard because that was just a lot of parameterization with Ansible, and it was just like all the repos, all the registries, all the images, and it was kind of a mess. So we hope that with this Kubeflow-based solution, it will be a bit easier. And also Kubeflow was working on that in the past. I'm not 100% sure if they were able to finish it, but we will definitely look at the Kubeflow solution for that, but that there is any. And if not, maybe we can help or finish or bring it back to the community and see what they have in mind for that.
Cool, thanks. I know because we had someone come to the OKD working group who wanted to do on ARM64 an ML use case using OKD in a disconnected fashion. So I think maybe OpenDataHub is a bit overkill for what they were trying to do, but I think it gives them a good roadmap and a good maybe a collaboration point to work through. So I'll see if I can feed you that use case as well.
I think it's an interesting point whether OpenDataHub is overkill. You don't have to use all the components, right?
Yeah.
If your only reason to run OpenDataHub is to deploy Selden and something else, then maybe it's still good to use OpenDataHub because we have verified the components that they run well on OpenShift, and there are some integrations and there is more coming. If it's just one component and it's already an operator hub and we just depend on it, maybe it doesn't make sense to run OpenDataHub. But if it's like 3 things that you would be running, it gives you kind of a single point where you just apply that one custom resource and it all comes up and it's all integrated and configured.
In the background there, did you get that working, Landon?
Yes. So just so it doesn't look like magic or anything, what we did, I was playing around with the KFDef. The operator was kind of throwing an issue with Grafana deployment. So it was kind of a timing issue. So we're relying on OLM to deploy Grafana based on the Grafana devs configuration. Since we have it separated into kind of Grafana cluster and the Grafana application, we kind of needed like a little wait time in between the two of a few seconds. So one of the dependencies that the Grafana deployment required wasn't present yet. So that would have been deployed by Grafana cluster. So it was a small race condition. So I'll just go over what we did. As always, when you have a problem, try the simplest solution. So I went to the KFDef and I moved the Grafana component to the bottom. So this is pretty simple. So I just cut this text from higher up in the KFDef YAML and moved it to the bottom. What happens is once we save that, it'll trigger an update, which the operator will detect, and then it will reprocess that KFDef. So now there's, based on the previous attempt to deploy Grafana, all the dependencies were installed, and now we can deploy Grafana successfully. So that's all I did. And what I did was kind of unblock the dam. So once that was resolved, all the below components, or the components below Grafana, deployed successfully. So you'll see we have a lot more deployments. And we have now Argo is available. Grafana is online. And JupyterHub. Then here we can just sign in. Luckily, I didn't expose my password to the world. And again, so we're using OpenShift OAuth for a lot of these components by default. And here, this is one of the customizations we've added to JupyterHub, where you can select your notebook from a list of notebooks. So we have kind of a minimal notebook, which is just kind of bare bones. I think it's just Python is installed. SciPy notebook for the SciPy library, a Spark notebook that has version Spark 2.45 and Hadoop 2.7.3, a Spark SciPy notebook and a TensorFlow notebook. So any user that deploys this has access to this. So if they can kind of read access to the namespace, basic kind of minimal access to the namespace, they can deploy their own notebook. And we have different sizes. So if you have a team that needs different size notebooks, there's an ability, these are the defaults that we provide, but you can provide your own custom resources. So even internally and externally, we have support. So if you wanted to change the small, medium, large configurations to be kind of 10 CPU and 256 megabytes or gigabytes of memory, or even larger than that, where you have kind of small CPU but large memory, you can do that. And if the user wants to add any environment variables, they can. And then they just spawn the notebook. So this is under full control of the user at this point. They don't have access to the project space where JupyterHub is running, but they have full access to their notebook pod. So if anybody has any questions about kind of the process we went through to kind of debug this, or any questions about any of the components, feel free to ask.
I think Beverly has a couple more queued up here.
Yeah, so we've got a question. Since OpenDataHub is a platform or blueprint to building an AI as a service platform. Can you talk into whether it works with GPUs?
So yes, it does. So we have full support for GPU. So the OpenDataHub does not do GPU enablement, but the notebook that we just spawned, a user has an option of requesting enable GPUs. So I think, so let's do a quick shout out to OpenDataHub.io. We have a quick guide for how you can utilize GPUs in OpenDataHub. So we have links to upstream partners. So right now in AWS, you can add a GPU node, and you would use the NVIDIA operator that's available in, I'm not sure if it's Red Hat operators or community operators.
I
But
think it's Red Hat operators, I'm pretty sure, but I will double check.
Okay, so since it's in Red Hat operators, you will need a kind of fully subscribed cluster, if I'm not mistaken. But the access to the NVIDIA operator is free. I'm using air quotes. So if your cluster has access to Red Hat operators, then you have access to the NVIDIA operator. So the NVIDIA operator is responsible for doing GPU enablement. So you provide the GPU node, install the NVIDIA operator, and then that will handle kind of usually it requires, there's an auto dependency that's installed. The node feature discovery operator is a dependency for NVIDIA that will essentially catalog every node in the cluster, and it will give you all these these labels for different hardware features that are available. And once it sees this annotation, the NVIDIA operator will go out to that node, install the appropriate drivers for the GPU that's installed. Once that's installed, you should get this line here when you describe the node. So if you OC describe that GPU node and you see this value, a non-zero value, that means that you have whatever this number is, that many GPUs available for requests. So at this point, OpenDataHub can request X number of GPUs. And then from there, you can spawn any notebook with that will request the GPUs, and then you could use that in your model development. So you have full access to that GPU. I think right now, all of our examples use TensorFlow to crunch the numbers, GPU. Hopefully that answered the question.
Yeah, that was great, Landon. And can you talk about what the AI library is?
That's a good question. Maybe Chad has an answer for that. I know he's done some work with the AI library.
If you pop over to the docs, there's a little overview on what AI library is there, and it's just...
Okay. Here we go. The AI library is an open source collection of AI components, machine learning algorithms, and solutions to common use cases to allow rapid prototyping. So again, if you have any questions about like any of the components, if you want to know more about them that we provide in OpenDataHub, feel free to go to OpenDataHub.io. We're always improving the docs and increasing the amount of documentation that's available for different components. So as we add a new component or update a new component to add features, it will be available on OpenDataHub.io website. But I think it's a collection of models that you can use in your workflow. And we're using Seldon. So Seldon is a dependency for the AI library where any of these models will be deployed and the API will be available for you to submit data to.
Okay. Then back to the GPU topic, we just got a question coming in from Oleg on YouTube. How to automatically run CALs on free GPU. Is there any spawner for that? GPUs with some RAM available? Not sure.
So how how is it generally working in OpenShift with GPUs? It's basically that the container, when you're spawning a container, and it requests some resources that can be CPU, memory, or any special resources like GPUs. The container will run on that node, and based on the configuration, it will get those resources. So for memory, you ask for 100 gigabytes of RAM. If you have a node which can accommodate that container, it will get that. If it's GPU, if there is a node that has a free GPU, unassigned GPU, it will get that GPU. Right now, there is no good solution, as far as I know, for like splitting GPUs or something. So if we are talking about using a GPU, it will be one GPU per container or multiple GPUs per container, but cannot be multiple containers per GPU. There are hacks around it, but it doesn't really work yet. So for this, we cannot automatically run. So if you just say in your code running in a container, hey, if there is a GPU, I'd like to run this on GPU. That's not how it works. The container, the pod itself has to specify that it requires a GPU to run. And if there is a free GPU, it will be assigned to that node, and it will be run on that node, and it will get the GPU kind of mounted into the devices of that container, and the code inside the container can use that. Problem with that, as long as that container runs, the GPU is allocated and cannot be allocated to something else. So there is no smart way right now to, let's say, okay, if there is a free GPU, run on GPU. If not, do not run on GPU. We don't have that, and I don't think anyone really has. Potentially, you could write an operator which would take your code and inject some information whether there is a free GPU or not, and then based on that, the code would change the execution path, and then maybe based on the information from the cluster, it would either get or don't get GPUs. But I haven't seen such solution yet. But in general, there is no automated way how to decide this available in OpenDataHub or in OpenShift in general.
Cool. Thanks for that. And I'm looking at the time, and we're almost to the end of the hour. So maybe, Landon, if you want to share that slide where people can find additional resources again while we blather on a little bit more, that would be a great way to end the hour here. And I'm just wondering, because you have lots of different partners and different integrations into this, have you done anything, just because they are now part of our family, with the IBM Watson stuff? Has anyone integrated any of that into and used it from a Jupyter notebook? Or is that something for a future briefing?
We actually have an issue created where IBM provides a CUDA-enabled container image, where we basically cannot redistribute them as OpenDataHub and as Red Hat. We cannot redistribute CUDA binaries in our images. We always have to build it on spot. So if you deploy OpenDataHub and you want to use GPUs and you want to have CUDA-enabled images, you have to build them in your cluster, which is fine. We provide all those build configs and everything. It just takes time and some resources for the build. Whereas IBM provides these images in actually Red Hat registry. So we have an issue for looking at whether we can use that image as a base for some of our Jupyter Notebook images, so that we don't have to build them, but we can actually leverage what they already provide. On the other front, IBM is very active in Kubeflow community, so we are talking to them often in our community calls and in Kubeflow community calls, and coordinating basically the Kubeflow operator, which is a base for OpenDataHub operator now, has been built by IBM team with our guidance, contributions to ideas, documentation, and some code. But they did majority of the work, the open source team at IBM. So really good collaboration there.
Awesome. Well, we're going to have soon and see if we can't make that all work and explain how that all works too. So I really want to thank Beverly for stepping up and organizing this today and making it happen, and the whole team from OpenDataHub for coming and answering questions and sharing your wonderful project, and congratulate you on it's really come a long way since the last time I did an open upstream conversation on it. So it's I know I've been talking with folks like Guillaume Moutier around some of the work that he's doing up. I'm up in Canada, as is Guillaume, and with the COVID project that the Ontario folks are doing, and hopefully we can get him back on again talking about that some more. I think we did a briefing a little while ago, but I think a lot of people out there in lots of different spaces are leveraging what started out as simply a reference architecture and has turned into a real community around things. So kudos to y'all for making this happen, and thank you, Landon, for making the demo work and explaining the fix. And we will have you guys back again soon for new updates and new use cases for this. So again, here's all the information you need to find everybody. And hopefully we'll get your feedback and have a few of you on showing us what you're doing with ODH soon. So thanks again, everybody.
Thank you.
And we will upload this